All right, y'all go and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll show you the correct answers. So on this factoring, you're going to start off by factoring out the 8x that they have in common. And so you're going to be left with x squared minus 4. And then that will factor as x minus 2 times x plus 2. And so this would be your answer. For the math knowledge question, it asks about how many cans of varnish they need to put one coat of varnish on the floor. Well, they tell us it's a 60 by 80 foot room, and so the area that we're needing to cover is 4,800 square feet. And we can use exactly 19.5 cans, no, 19.2, I'm sorry, 19.2 cans if we had to get a part of a can, but you can't get part of a can. So that would have to go to 20 cans of varnish that you would need. Okay, so we are looking at lesson 81 today. We're looking at the law of cosines. So hopefully after this lesson you'll understand the law of cosines. We did touch briefly on this in geometry, so maybe this will look a little bit familiar to you. So if you have a right triangle, you can use sine, cosine, and tangent to find your missing parts. Anytime you have a right triangle, you just use your sine, cosine, and tangent. Like what we've been doing, you started doing that in Algebra 2. If your triangle is not a right triangle, but you have a pair of values known, an angle and a side pair, then you can use the law of sines that we talked about a couple weeks ago. However, if you have a triangle that is not a right triangle and you do not have an angle and a side pair, then you would use the law of cosines. Okay, so that's when you're going to want to use the law of cosines. If you try and use the law of sines and it's not going to work, you're going to have to use the law of cosines. This is the law of cosines. A squared equals b squared plus c squared minus 2bc cosine of a. You can also write it where you have b squared equals a squared plus c squared minus 2ac cosine of b, or you can write c squared equals a squared plus b squared minus 2ab cosine of b. It's all the same thing, it's just switching around the letters basically. On this, whatever side is over here by itself, you're going to be having the angle for the cosine value. And then we've got BC here, and you have B and C there. And so you do have to memorize one of these. You don't have to remember all three of them. They're the exact same thing, just different order of letters. But you are going to have to know it to be able to use the law of cosines. So we want to solve this triangle for its unknown parts. Well, we know two of our sides and we know an angle. None of them are a pair, so we have to use the law of cosines. The one that is going to make the most sense to use is to solve for x, because we know its angle. So we would say x squared equals 7 squared plus 10 squared, and then minus 2 times 7 times 10, and then the cosine of 36. And so now we're just going to simplify that. And so you have x squared equals 149 minus 140 cosine of 36. And so you're going to have to use your calculator there. And I get that x squared equals 35.74. Now, part of some people's problem is they say x equals 35.74 and they move on. But that's not what our x value is. That is x squared. So you have to take the square root and you get that x equals 5.98. So that is your x value. Now we have an angle and a side pair. Okay, and we can use the law of cosines, the law of sines instead of the law of cosines if you would like. You don't have to. If you really like the law of cosines, then you can use it. But I can set up a law of sines by saying 5.98 over the sine of 36 equals 10 over the sine of y equals 7 over the sine of m. Now, on the law of sines, remember that you do have a little bit of ambiguity because we are always going to be given an acute angle when sometimes our angles may be obtuse. When you're dealing with the law of cosines, you won't have that ambiguity if you find an angle. So I recommend that if you have two angles you're solving for, always pick the one that is definitely going to be the smaller angle to solve for first, and that way you don't accidentally, like for y, it kind of looks like it may be obtuse or it could be acute. So I'm going to solve for it after I have m, because m is definitely an acute angle. It's smaller than angle y. So I'm going to not use the 10 over sine y. I'm going to use the first and the last one. So I'm going to have 5.98 sine of m equals 7 sine of 36. And so you're going to divide by the 5.98. And you're going to get sine of m equals some number. You should get like 0.69. Now remember, whenever you do the sine inverse to get your m, you need to use that whole decimal that your calculator gave you. Don't just use this number here. And so m should be 43.49 degrees. Okay? And so we can now just do 180 minus 43.49 and minus 36 to get that y equals 100. And so that would be your three missing values. Now, I'm going to show you, using the law of sines, with these two ratios, what I'm talking about for your y, just in case you forgot. You would have 5.98 sine of y equals 10 sine of 36, and divide by 5.98. And so the sine of y is going to be 0.98, and take the sine inverse of that, and you get y equals 79.49, which is not the correct value. But it is kind of hard to tell if it's actually obtuse or acute, just kind of looking at the picture. And so that's why I recommend always solving for the acute angle first, and then you don't have to worry about trying to figure out, oh, is that right or is that not right? You just know for sure, since this is 43, this one is going to have to be about 100. Okay, so let's look at another example. We've got all three sides and we have none of the angles. So on this one, it doesn't really matter which angle you solve for. You're going to have to solve for all three of them. So I'm going to start with 8, and I'm going to solve for y, because that's the biggest angle. And with law of cosines, you won't have to worry about any ambiguity for the angle size. So we're going to have 8 squared, and then 5 squared plus 7 squared minus 2 times 5 times 7 cosine of angle y, because that's the one that is opposite the 8 right here. So I have 64, and then 25 plus 49, and then minus 70 cosine of y. So 64 minus 25 minus 49 is negative 10, and negative 70 cosine of y. So divide by the negative 70, and I have 1/7 equals the cosine of y. So now you need to do cosine inverse of 1/7, and y equals 81.79 degrees. So that is our y value. We don't have to worry about is it an acute or an obtuse angle when you're dealing with the law of cosines. So now that we know that y is 81.79, we can set up our law of sines. Now if you would like, you can do this exact same thing and just use a different side instead of the 8, and that would give you a different angle. So if you prefer using law of cosines, you're certainly able to do this exact same thing 2 more times or 1 more time to get a second angle, and then just subtract them from 180 to get the 30. So we can do that if y'all would like to practice the law of cosines, or you can do the law of sines. So I'm going to do the law of cosines just so y'all can see what I'm talking about. But if you want to do the law of sines, you're more than welcome to. And so the angle that we're looking for is now x. So we have 49, and then 64 plus 25 minus, wouldn't that be 80? And then 49 minus 64 minus 25 is negative 40. So divide by negative 80. And I get 1/2 equals cosine of x. Well, that means that x is a 60-degree angle, because the cosine of 60 degrees is 1/2. So that gives me 2 of the angles. And so just subtract those from 180, and then the third angle would have to be 38.21. And so that would be your missing 3 parts that you need to solve for. Okay, let's look at another one. We want to solve the triangle for the unknown parts. So they give us 2 sides and an angle. So the one that we're going to want to solve for first is k, because that's opposite the angle that they give us. So k squared equals 14 squared plus 10 squared minus 2 times 14 times 10 cosine of 28. So 14 squared is 196 plus 100, and then minus 280 cosine of 28. So we have k squared equals 296 minus 280 cosine of 28. One thing to point out, do not do 296 minus 280 and then the cosine of 28. It is 280 times the cosine of 28, and then you'll subtract it from the 296. I have had people do that before. Do not combine these two numbers and then multiply it by the cosine of 28. So 296 minus 280 cosine of 28 is going to give me 48.77, and so that's k squared. So k is the square root of that, which is 6.98. So that's your k value. So now we can do law of sines, or we can do law of cosines. I'm going to do law of sines and find my angle B. So I'm going to say 10 over the sine of angle B equals 6.98 over the sine of 28. And again, the reason I'm not finding m is an obtuse angle, and I don't want to have to remember to subtract whatever I get from 180 to get my m value. So I have 6.98 sine of B equals 10 sine of 28 divided by the 6.98. And so the sine of angle B is 0.67. And so you're going to do the sine inverse of that whole decimal that they gave you in your calculator, not just the 0.67. And so your angle is going to be 42.24. So that's angle B. And then to find angle M, we're going to subtract that and 28 from 180. And so angle M is 109.76 degrees. And so those would be your 3 missing values. Okay? Now we're going to look at one more example. Now this is a common example that they like to give you in your homework. And tonight they are going to draw the picture for you. And then when you look at lesson 82, if it gives it to you, it's not going to draw it. Same thing with lesson 83 or 84. They're not going to usually draw the picture. They're just going to give you the words, and then they're going to expect you to understand how to draw the picture. So if you look, we have 2 cables that are attached from a point on the ground to some pole. Okay? And the angle between them is 15 degrees. So this angle here is 15. The longer cable is 150, and then it's at the top of the tower. And the shorter cable, we don't know how long it is, but it's 50 feet from the top of the tower is where it is attached. And we want to find the length of the shorter cable. Now on this one, we actually don't have to use the law of cosines here. We can just use the law of sines. I'm not exactly sure why they waited to put this in with the lesson for law of cosines and why they didn't do it with the law of sines. But you actually don't need the law of cosines on this problem. So we're just going to set up all of our angle pairs and our side pairs. We're going to have 50 over the sine of 15, and then 150 over the sine of b, and we're going to solve for b. So I'm going to have 50 sine of b equals 150 sine of 15, and you're going to divide by 50 and plug that into your calculator. And you should get that the sine of b is 0.78, and so b, use that whole decimal, sine inverse of it, gives you 50.94. Now if you look at the picture, does b look like 50.94 degrees? No, it's an obtuse angle. So we have to do 180 minus that. So my b value is actually going to be 129.06 degrees. Okay, so that's b. Now I can find this angle up here. So I'm going to say 180 minus the 129 and also minus the 15, and that's going to give me 35.94 degrees. And so I can add my third side L over the sine of that third angle, 35.94, and I can use it and the first ratio to solve for my missing side. So I would have L times sine of 15 equals 50 sine of 35.94, and then I'm going to divide by the sine of 15. Okay, and so if you plug that into your calculator, you should get that L equals 113.38, and it is feet, and so that is the length of the shorter cable. Now, the longer cable was 150, so if I got something that is greater than 150, then there's no way that that's going to work. Okay, so you may not be able to tell where you went wrong, but you do at least know that your answer is wrong because you got something that's longer than the longer chord. Okay, so hopefully that helps you with the law of cosines. On your homework, make sure that you do 1 through 30, and then we'll go over any questions that you have tomorrow.